Welcome to the session, all of you. In this short session, we are going to learn about cutting of cubes and we'll arrive at a formula at the end of the session. Cutting of cubes, you find in the non-CAT paper. You also sometimes find these kind of questions in CAT, although it's rare. But in the non-CAT paper, definitely you have a lot of questions coming up in the last 10 years if you look at papers like SNAP, the NMAT, and even MAT and CMAT. So let's understand how we go about looking at the concept. So in a cube, you have a total of 8 corners. So 4 at the top, 4 at the bottom. You have 12 edges, 4 on the wall, and then you have 4 at the top and 4 at the bottom. And then you have 6 faces. This is something that we'll remember because cutting of cubes is based on this. And when we are looking at cutting of cubes, we'll need to know how many corners, how many edges, and how many faces are there. Based on that, we can arrive at the answers. Now, if you look at a cube, most of the questions in the cube chapter comes from having a cube, taking it and then cutting it equally at each of the axes and making it into smaller cubes. Now, you'll get questions like a cube is painted on all the faces and then it's cut into smaller cubes. And then they'll ask you a question as to how many cubes are 3-side painted, 2-side painted, 1-side painted, so on and so forth. So basically, we are looking at making same number of cuts in every axis. So here, if you see a cut like this, a cut like this, and a cut like this, same is the case here as well. 2 cuts on this axis, 2 on this, and then you have 2 on these axes. Same here, 3, 3, and 3. So based on this, we will look at how we can look at a formula to generalize cutting of cubes by looking at 1 cut per axis, 2 cut per axis, 3 cut per axis, and then generalizing it to n cuts per axis. So I'm going to make a small table like this. So here you have the number of cuts in the first column. You have the total number of cubes formed, total number of corner cubes, number of edge cubes, number of face cubes, and number of inner cubes. So when I'm saying corner cubes, it will have 3 sides painted. Edge cubes will have 2 sides painted. Face cubes will have 1 side painted, and inner cubes, none of the sides will be painted. So now if I look at a cube like this and cut it from one time from each of the axes, you will land up with 8 cubes. So total number of cubes will be 8. And because the corners are 8, so all those will be 3-side painted cube, which means there'll be no 2-side painted, no 1-side painted, and no cube, which is an inner cube. Let's look at how it will look like when you are having 2 cuts per axis. So in this, I'm going to make 2 cuts per axis. So if you see on the top, you have 9 cubes. Here you have 9 cubes. Here also you have 9 cubes. So totally 27 cubes. 8 of them are corner cubes. So you can well remember here that, the corner cubes are always going to be a constant and it will never change because the number of corners don't change when you're cutting the cubes, isn't it? So it will be 8. If you have 1 cut, 2 cut per axis, 5 cut per axis, or 100 cuts per axis, it's not going to change. Here, if you look at the edges, you have just 1 cube here, 1 cube here, 1 cube here, 1 cube here. In every edge, you see there is only 1 cube, which will be 2-side painted if you remove the corner cubes. So total number of cubes in every edge, which are 2-side painted, is 1, and there are 12 edges, so it will be 12 into 1. If you look at this particular cube, which is there in the middle, this is a cube. This is a cube which is a 1-side painted cube, and there'll be 1 on each of the 6 faces. So 6 into 1, total 6 cubes there. So if you look at this, 27 was the total number of cubes. 12 of them are 2-side painted and 8 of them are 3-side painted. Total 20 cubes there. And 1-side painted is 6, so 26 cubes. So one of the cube which is left will be an inner cube with no side painted. Let's look at 3 cuts per axis. And you will see that there are 16 cubes here, 16 here, 16 here, and 16 here. Totally 64 cubes. 8 of them are corner cubes. On every edge, you have 2 cubes. So 12 into 2 is the total number of edge cubes. And on every face, you have 4 cubes. So 6 into 4, 24 is the total number of 1-side painted cubes. So you have 12 into 2, 48. Sorry, 24 here, 24 here, and 8 here. So totally you will have 48 plus 8, 56 cube, balance is 8. So total number of cubes will be no side painted is going to be 8. So we can extrapolate this for n cuts per axis. So if you do n cuts per axis, you will have n plus 1 the whole cube number of cubes. 3 cuts, 3 plus 1 the whole cube, 4 cube. 8 of them will be corner cubes and that will be the 3-side painted cubes. 12 into n minus 1 will be the total number of cubes which are 2-side painted. 6 into n minus 1 the whole square. See 1, 4. So it will be n minus 1 the whole square which will be 1-side painted and n minus 1 the whole cube will be no side painted cubes. So this is a formula that you can use for cutting off cubes. It's applicable everywhere. Just remember that we are talking here about n, which is the number of cuts per axis. If you take n as something else, this formula is going to change. This formula is applicable everywhere in all kind of cubes question, barring the cuboids question, because cuboid question, the dimensions do change. So you cannot take a straight formula. It will change based on how the dimensions of the cuboid look like. So this is all about cutting of cubes. Hope you find this useful. So thank you for watching the video.